So, good afternoon, guys. This is Marco Belby Falcon, and for this afternoon, I'm going to discuss about the network communications and protocols. So, it is the chapter 6 for the subject networking. So, in this topic, we will discuss about the protocols, access methods, and in my part, I'm going to discuss about the packets. So, let us proceed. Sorry for the outward noises again, guys, because I have no conducive area to make my report. So, first of all, what are packets? So, okay. Okay. Okay, so let us just skip that part. So the packets have three parts. So, first is the packet header is the portion of an IP internet protocol that precedes its body and contains addressing and other data that is required for its reach intended destination. Next of all is data section of a packet consists of the actual data being sent. And next is the packet trailer contains information to verify the validity of the packet contents. So overall, ako na lang siyang i-explain sa Bisaya na lang para mas masabtan. So, kaning packet mo na siya kung marag ang agianan sa mga data nga kanang ginasend like mga data nga mga little bit of information. For example, kung sa computeran is naman na ang main computer mismo. Bale, ginaunsa man na siya nga para ang kanang main computer is maka-set siya og kanang like time sa designated gapon na computers na nakabutang like kung na-sketch pa lang na siya sa floor plan mismo, ang main computer mismo nanay marag I think parts or na area na kung nakakonect ang IP kung kanada yung mga internet protocols din kay mga little bit of data mo din ang ginasend din sa designated na mga computers o mana siya mostly ang sa packet. Sorry kayo kung wala kayo na ko siya further kayo na discuss well. So, I will try my best na ako sa siyang i-discuss pa further sa inyo og ayo. So, let us go to the next slide. Sorry. So, wait. Sorry. Okay. Understanding packets. So, nakabutan dere is, so your computer is connected to the internet and has a unique address. How does it talk to other computers connected to the internet? Examples of it should serve here. So let us say your IP address is 1234 and you want to send a message to the computer 5678. the message you want to send is hello computer 5678. Obviously, the message must be transmitted over whatever kind of wire connects your computer to the internet. Let's say you've dialed into your internet service provider from home and the message must be transmitted over the phone line. Therefore, the message must be translated from alphabetic text into electronic signals, transmitted over the internet, then translated back into alphabetic text. How this is accomplished? Through the use of protocol stack. Every computer needs one to communicate on the internet and is usually built into the computer's operating system, i.e. Windows, Unix, etc. The protocol stack used on the internet is referred to as the TCP or IP protocol stack because of the two major communication protocol used. So, ato na lang siyang ibutang sa example kanya. For example, let's just say nga sa computer lagi main, para ma-further na ako sabot sa inyo about ang kaning purpose sa packet here is a diagram nga ako mapakita sa inyo. So, let us say sa application SF. So, sa SF mismo, ginaunsa man like ang isa ka player sa first, second, third, or fourth computer, mag-match up sila sa isa ra gyapon ka server ug ang kontra gyapon nila isang other servers. It's other computers, which is the 5, 6, 7, 8. So, kanitanan nagaagi, for example, mga data, mga gipang send sa Facebook na mga links, mga information, kay ano pa na siya, dili na siya ingod nga direct na ma-send siya instantly. Bale, napa siya kanang i-follow good na process ana, like from the application, for example kani si computer 1 nag-send siya og computer 8 og message. So dili pa naingon nga direct yun na direct na siya mo-send. Pero ang kanang data nga ga-flow moagi pa na siya sa ginatawag lagi nato nga protocol stack. Bale ano pa siya? For example, nag-type ka og hello. Kanang word na hello na siya ginasundan nga binary code. Nang before siya na ma-transfer dadto sa imong sandan nga computer, moagi pa na sa process nga ang alphabetic text, mo process pa siya into like electronic signals, and then ayan na po din siya ma-convert into alphabetic text. Sa diya nga aspect makuan ang sa diya nga aspect, diya na dayon mosulod dayon sa atong ginatawag na si protocol mismo. Like ang purpose man gid sa packet, bali siya mo ang kung sa communication, kung ikaw sender, siya mismo ang ga-travel sa message, siya ang ga-deliver. Gikan sa mismo nga data nga siya gisend, moagi pa na siya sa muagi pa na siya sa protocol nga TCP ug IP, i-convert pa na, tapos ikuha din sa hardware, ayo din mo proceed dayon sa internet. Tapos after na din makuha din sa internet is makuha na po dayon siya sa hardware na po dayon siya isundan nga IP o TCP. Dili kayo na ko ingon nga major yun kaya ang IT. But sa akong understanding ani nga na concept is like, ang purpose sa TCP and sa IP, bale, protocols siya na gina-follow in all kinds of electronic media transmission of mga data, images, information, personal information, business. Bale, kung kakita pa mo sa salida sa matrix, ang internet muna na siya katong mga codings nga 001, 110, o kada data na siya gina-follow na binary code sa pag-interpret. O ang TCP o ang IP protocol, muna sila ang duha ka mga protocols na ginagamit para ma-send ang data, ang alphabetic text, i-convert siya into electronic signals, which is more lagi from the alphabetic text, i-convert siya into a binary code, and then mag-proceed na po din siya sa hardware, which is dato lagi nakapresent na yun na ang mga binary codes, like mag-transfer until na makuha na po din siya sa internet, until then that na yun sa designated na yun nga kuan. Sama na ganit po ng mag-time na ang main nga computer nga tig time, bali ang iyang system ang dagat niya sa system is gi-built-in na siya nga program nga siya may mag-handle bali gi-built-in na sa program sa computers nga siya gi-connect na ikuan like ma-time, ma-record. Dili gid na ko man siya ma-explain further ang concept, pero if I will put this again into simpler concepts, so wait lang. So in basic explanations, so ang message, data, information, whatever kind of information na nakapresent ana is the text, the data, whatever it is, will be converted into electronic signals, transferred into the internet, translated back into alphabetic text, and then ma-proceed na po din sa application. Ang nagdumala ana is ang packet. Ang nagdumala ana is ang packets, bale. Okay, So ang purpose good ni packet good is siya mo'y ang gakuan nga like body o gina-address niya ang other data that is needed to its intended destination. Ang data section balik is consists of data actual being sent, and packet trailer contains information to verify the validity of the packet's content. So, how packets are created? So, atong i-point kung unsa ang 7 key points in data transmission. So, paano ba siya ginakuan? So, sorry kayo kung gamay kay ang akong mga text. Bear with me. So, first, your computer creates a packet organized in a very specific way that the receiving computer can understand and use. Balimanay lang way of communication. This entire packet or stream of data is broken down into a specific number of bytes, 8 bits of zeros and ones. Malagita kong gayon ganina, which is ang codes, which are individual packets that are part of the big data packet. Each packet holds about 1,000 to 15 bytes. So the packet as a header. To the packet, your computer adds to the IP address of the computer that your data is supposed to get to, and puts your IP address on it too. Your computer adds 2 identifying numbers to each of the smaller packets. The first number represents the number of packets that all of the information is divided into. The second number represents the number of each individual packet among the total sequence of packets. Your computer's internal networking hardware and software are follow guidelines for bundling the data that you are sending out the payload. Those guidelines are spelled out in the Transmission Control Protocol, Internet Protocol, TCP, and IP. Each packet also has a trailer or footer, which contain a few electronic bits that tell the receiving computer when it's reached the end of the packet sequence. It might include the results of the cyclic redundancy check, CRC. This contains the sum of all ones in the packet added by your computer. The receiving also does the same math, and if the math doesn't add up, it may ask your computer to retransmit the packet. Your computer sends each packet on the internet separately, and each packet takes the best route available at the time where it can go. Why does it happen this way? So that the network can spread data traffic evenly, and all your data won't get stuck or slowed down in one spot. Keep in mind, a traffic jam might only last in a fraction of a second. So, sa akong giingon na 7 key points in data transmission is, mo ni siya ang way kung ginaunsa nga ang data gikan sa atong mga load, like for example, Smart, TM, Globe, is gina-transmit ang kanang nga data padulong sa atong mga applications na ginabutang. Mani siya parang ang summarized process. And even also when it comes to like online games or whatever it is nga like kuan lagi ka nang, how is it possible nga ang, for example, ang upat na computers makontra gyapon na ng 5, 6, 7, 8? It's because also of the data transmission itself na gikan ra sa kuan gyapon, isa ra ka internet o sa server nga aha na involved tong kuan so sila nga game. So mara ni tanan ang akong ma-explain about the first part. Og next is anduan nako kakauban si Miss Aiza Redera and si Miss Alisa Flores kay i-discuss about much more about sa protocols and about sa access methods. So, good afternoon sa inyo, everyone day, and stay safe.
Good evening, everyone. I am Aiza Deredera from base TCM to K3. I will tackle about protocols. So, let's start. In networking, a protocol is a set of rules for formatting and processing data. Network protocols are like a common language for computers. The computers within a network may use vastly different software and hardware. However, the use of protocols enables them to communicate with each other regardless. So there are functions of protocols. First, detection of the underlying physical connection, or wired or wireless, or the existence of the other endpoint or node. Next is handshaking, dynamically setting parameters of a communications channel. Next, negotiation of various connection characteristics. How to start and end a message. How to format a message. What to do with corrupted or improperly formatted messages or error connection. How to detect unexpected loss of connection and what to do next. Termination of decision and or connection. TCP or IP, Transmission Control Protocol. So there are types of common protocols. So first, the Internet Protocol Suite, commonly known as TCP or IP, is the set of communications protocols used for the Internet and other similar networks. The Internet Protocol Suite, like many protocol suites, may be viewed as a set of layers. Each layer solves a set of problems involving the transmission of data and provides a well-defined service to the upper layer protocols based on using services from some lower layers. Upper layers are logically closer to the user and deal with more abstract data, relying on lower layer protocols to translate data into forms that can eventually be physically transmitted. The TCP or IP model consists of 4 layers, from lowest to highest. These are the link layer, the internet layer, the transport layer, and the application layer. So, second is the Address Resolution Protocol or ARP. It is a communications protocol used for resolution of internet layer addresses into link layer addresses. A critical function in the Internet Protocol Suite. ARP was defined by RFC 826 in 1982 and is Internet Standard STD37. ARP is also the name of the program for manipulating these addresses in most operating systems. ARP is used for mapping a network addressed, example an IPv4 addressed, to a physical address like an Ethernet address, also named a MAC address. ARP has been implemented with many combination of network and data link layer technologies, like the following. So the second is DHCP, Dynamic Host Configuration Protocol. This is a protocol that is used to assist users to configure multiple network devices from a single source. This protocol is used to assist a user in configuring multiple networks. The third one is DNS, Domain Name System. This is a protocol that assists the users by helping to link between common usernames, works to an IP address and back. Example, instead of cramming the IP address for Wikibooks, the user can easily type https www.wikibooks.org to be able to access the content from there. The fourth one is FTP, a file transfer protocol. FTP is a standard internet protocol for transmitting files between computers on the internet over TCP/IP connection. Standard internet protocol for transmitting files between computers on the internet over TCP/IP connections. It is a client-server protocol that relies on 2 communication channels between client and server, a command channel for controlling the conversation, and a data channel for transmitting files content. Clients initiate conversations with servers by requesting to download a file. Fifth one is HTTP or Hypertext Transfer Protocol. This was the initial protocol that was used to access web content. It was replaced by HTTPS due to its security vulnerabilities. HTTPS Hypertext Transfer Protocol Secure. This is the secure version of HTTP that is now commonly used to access websites' content. This protocol allows for the use of encryption. You can see when they are in use because the URL begins with HTTPS and a padlock icon appears in the status bar or browser bar in the browser window. HTTPS is the worldwide standard that is used for payment transactions and for other data-sensitive internet transactions. Next is ICMP, or Internet Control Message Protocol. Internet Control Message Protocol, or ICMP, provides feedback that you can use for diagnostic or to report logical errors. The most common ICMP type is the ping. The designers of ICMP envisioned a protocol that would be helpful and informative. Unfortunately, hackers have a different vision. They use ICMP to send the ping of that, smurf those packets, query the timestamp of a system or its netmask, or even send ICMP type 5 packets to redirect traffic. So, implementing protocols. Protocols are generally built upon each other. At the risk of sounding pedantic, here's an example of protocol and how it's implemented. First is application protocol. The way a particular application talks to another instance of itself or a corresponding server, this is implemented in the application code or a shared library. Second is TCP or UDP, or another layer, the way that information is sent at the binary level and split up into usable chunks, then reassembled at the destination. This is usually implemented as part of the operating system, but it is still software code. IP, the way that information, having already been split or truncated by something like TCP or UDP, makes its way from one place to another by routing over one or more hops. This is always software code, but is sometimes implemented in the OS and sometimes implemented in the network device, your LAN card, for example. Base T, Ethernet, token ring, etc. Here we are physically getting into how the hardware talks to one another. Which wire corresponds to a particular type of signal. This is always implemented in hardware. Electricity, the laws that govern or at least define how electrons or photons flow over a conductive material or over the air. This is usually implemented in hardware. In a sense, these are all protocols, a set of rules or expected behaviors that allow communication to take place, and they're built on one another.
Hello everyone, I am Alyssa Jade Flores, and in this video, I will be discussing about the access methods. So let's get started. First, what is access methods? So according to my research, it is a function of a mainframe operating system that enables the data on disk, tape, or other external devices. What are the functions of access method? It is when multiple computers are attached to a network. The way those computers share cable must be defined. When computers have data to send, they transmit data across the network. Okay, so next is the channel access methods. These provide additional assurance that the data reaches its destination by preventing two or more computers from sending messages that might collide on the cable. As with all other network communication parameters, every computer on a network must use the same access methods because if not, the data is not received, and depending on the method used, all network communications might be interrupted. Next is the major access methods. These are the 5 types of channel access. It is contention, switching, token passing, demand priority, and polling. So let us first discuss the contention. In early networks based on contention, computers sent data whenever they had data to send. This might work well in a small conversation where computers send a little data along the cable. But as more computers send a data, outgoing messages collide frequently, must be resent, and then collide again. To organize the contention-based networks, two carrier access methods were created, which is first is the carrier sends multiple access with collision detection or CSMA-CD, and the second one is the carrier sends multiple access with collision avoidance or CSMA-CA. So let us first discuss about the carrier sends multiple access with collision detection. It is one of the most popular ways to regulate network traffic. Used by Ethernet, this access method prevents collision by listening to the channel to see if another network is sending data. If the other computer senses no data on the line, it sends its message. If another computer is using the channel, the computer waits a random amount of time then checks again. Next is the carrier sends multiple access with collision avoidance or CSMA-CA. It is another channel access method that uses carrier sends multiple access. However, it uses collision avoidance rather than detection to prevent collision. With this, once the computer senses that no other computer is using the network, it signals its intent to transmit data. Next is switching. When networks interconnect individual nodes through a special device called a switch, the switch itself controls access to the media. Contention occurs on a switch when only two or more senders ask to reach the same receiver simultaneously, or when the number of simultaneously transmission requests exceed the switch ability to handle multiple connections. Next is token passing. It is a special packet called the token passes sequentially from one computer to the next. Based on my research, it circulates around the cable ring from the station to station. Plus, when any station on the ring needs to send data across the networks, it must wait for a free token. When a free token is detected, the station will take control of it if the station has data to send. Another one is the demand priority. So according to my research, it is a media access method uses 100 base VG, a 100 megabit per second Ethernet implementation proposed by Hewlett-Packard and AT&T Microelectronics, later standardized as IEEE 802.12. This access method is based on the fact that repeaters and end nodes are the two components that make up all 100 VG AnyLAN networks. The repeater or hub is responsible for noting all addresses, links, and end nodes and verifying that they are all functioning. Lastly is polling. Polling is one of the oldest ways to control access to the network, often referred to as the primary device. Ask each computer on the network if it has data to send. Polling is a method of controlling the access to a transmission medium which is shared by a number of stations. In polling networks, a controller is required to either initiate or to carry out the polling. Choosing an access method. It is an integral part of your network. The biggest factor in the choice of access methods is the network topology. The ring topology network generally uses the token passing channel access method. Switching is an exception to the topology constraint because switches support nearly arbitrary node groupings. So that would be all for my discussion. Thank you for watching. Bye!